Great, what I was saying. All right, so when we are analyzing in behavior of rational functions that have a numerator greater than the denominator degree, what we're going to pay attention to again is the numerator. So the numerator degree is what's going to dictate your behavior. Does that make sense when I said that? So notice that in the numerator, our highest degree is 5, and 5 is odd. So we know that ultimately we're going to be having odd behaviors, right? Its leading coefficient is positive, so we know that our right side is going to be going up, and therefore our left side is going to be going down, okay? Remember I talked to you about those hidden discontinuities? So when we graphed it, notice that did we see where x could not equal the cube root of -2? No, we did not see it, okay? So remember, there's going to be those hidden discontinuities that you would still have to be able to find because it's not necessarily an asymptote. And the reason why it's not an asymptote is because it's still growing. It's still ultimately going to keep getting bigger and bigger, right? But it is going to have that hole in the function. Make sense? Okay. So don't forget our hidden discontinuity. Pew, 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 pew. All right. So on this one, when we look at 3x minus 5x to the fourth, our highest degree, because our numerator degree is greater than our denominator degree, so we have no horizontal asymptote, right? Our numerator degree here, though, is more than 2 degrees greater, okay? Because it's more than 2 degrees greater, that means that we're going to pay attention to its behavior. This is a even degree function, correct? Because it's even, it's 4. We're going to pay attention to that. Even, so same behaviors, and its leading coefficient is negative, so my right side's going down and my left side's going down. And therefore, we can tell without graphing that the end behaviors are going to be going to negative infinity and negative infinity. Make sense? Okay. Now, then we looked at it graphically. That's not what I want to pull up. If I was a graph, where would I be? Somewhere. Right here. Is she cute? Okay. So it's going to open. So when we looked at it graphically, we had, remember, I'm lazy. Well, I'm not lazy. I just don't like using that bar if I don't have to. Equal. So I'm going to put mine in parentheses. 3x minus 5x to the 4 divided by x plus 2. Okay. Where is my hidden discontinuity? What was it at? At -2. My hidden discontinuity is at -2. I can confirm that by looking at the table, and at -2, it's what? Undefined, right? So again, the degree of my numerator is 4. The degree of my denominator is 1. That is 1 degree, more than 1 degree greater, right? So therefore, I know that it's going to behave like the highest degree, well, highest exponent, which is the degree of the numerator, okay? So it's going to behave like the degree of the numerator. My degree is a 4, even behaviors. Its leading coefficient is negative, which is why it was going to negative infinity, negative infinity, okay? So hopefully, if I didn't make that very clear on whatever that day was, that it is a little more clear now and that we're good with that. All right, so when we are writing our limit here, so the limit as x goes to positive infinity, f of x equals negative infinity, right? The limit as x goes to negative infinity, f of x equals negative infinity. Oh, that's an 8. Okay, but so this is really random. So my 5-year-old, he's like, Mom, I think you've been making your infinity symbol wrong, right? Why does he know what infinity symbol is? YouTube Shorts. So that's the conclusion I've come to. He's like, you're supposed to draw the X and then just circle. And there you go. And I was like, huh, okay. Apparently he learned that on YouTube Short. Why is someone drawing infinity symbols on YouTube Short? I don't know. But that's what my 5-year-old told me. So if you struggle making an infinity symbol, Elliot said, just draw an X and then make a circle. And that's how you do an infinity symbol. So, all right. But are we good with analyzing the behavior without a graph and with a graph? Okay. And what do we not need to forget? There are going to be hidden what? Hidden zeros, hidden discontinuities, right? Okay. It's a discontinuity because it's a point where it's going to be undefined, right? It's going to disconnect for a moment and then recontinue. Make sense? That's why it's called a discontinuity. All right, we have three types of discontinuities. The discontinuities are gaps, holes, and asymptotes. Gaps, holes, and asymptotes. All right, gaps, holes, and asymptote. Oh, I gotta find this t-shirt. It's like a math punny shirt. So one of my students made me a shirt and it said, holy shift, look at the asymptote on that function. And it's a rational function that's been shifted. And it's appropriate for this unit. See? Yeah. It's so, but, huh? It's unfortunate, but it's appropriate for this unit. I've been waiting till we got here to tell y'all that. So when I find the shirt, I'll wear it. But holy shift, holy shift. Look at the asymptote on that function. You get it? You get it? Yeah. Shift. Yes. All right. So now let's talk about when the degree is only 1 degree higher. Okay. So when the degree is only 1 degree higher, that's what creates what we call an oblique or slant asymptote. Okay. I'm going to be completely honest with y'all. If you were in Algebra 2, this is the very end of our Algebra 2. Okay. And at the end, you're probably like, all over the place. Okay. It is our long division. It is our long division way of finding it. So when you have this situation, so notice the degree of my numerator is 2, right? Degree is 2. The degree of the denominator is 1. There's only a 1 degree separation between the two, okay? What that creates is called a slant or oblique asymptote. Essentially, it's a linear function that is separating your rational function into two halves, okay? There's two ways of solving it. One is with long division. 2 is with synthetic division, okay? So we're going to divide our page in half, and we're going to model both. Okay, so again, as I was saying, we did briefly learn this. And I'm not going to tell you that it was probably the most in-depth way of learning because honestly, May is a blur. I don't know what happened in May. But we're going to talk about it. So on the left side of your paper, we're going to talk about long division. Do you guys remember learning long division in elementary school? Okay, good. I hope you did. So I learned long division. My teacher used the acronym Does McDonald's Sell Burgers? Okay. So does McDonald's sell burgers is the way that you remember how to divide long division. So the D stands for you divide first. You divide your first numbers first. Then after you divide, you're then going to get a quotient. You're going to multiply by that quotient. After you multiply by the quotient, you then subtract and then you bring down. Does that vaguely sound familiar? Yeah. Okay, do not write down what I'm about to do. Did you hear me? Do not write down. Okay, so for example, if I had 3 and I had 721, right? So the first thing you do is the divide. 7 divided by 3 is 2. Then you multiply. 3 times 2 is 6. Then you subtract 1, and then you bring down, right? Then you repeat it again. Does McDonald's sell burgers? Then you divide. 12 divided by 3 is 4. Then you multiply. 3 times 4 is 12. Then you subtract, and then you bring down, right? And then this is your remainder. Do y'all remember doing that? And you have like your R, remainder, 1, okay? All right, as you evolve, it should become 24, 1 out of 3, because that's what that is, okay? That's not just your R anymore. It's what you have left out of a third. Make sense? Okay. I didn't know this Jones. Why didn't you let us call? No, y'all could have called. I'm trying to still do my job right now. Okay. All right. So here we go. Y'all remember that, right? This looks familiar? Okay. Now we're going to take it out of elementary. Okay. We got to take it out of elementary. Okay. So we're dividing. So when you have a fraction, again, I think I just had weird teachers. A fraction, we automatically know it's a division problem, right? All right, so what I learned is the cowboy rides the horse. So the cowboy is going to go inside the house, which is x squared minus 6x plus 7. And the horse is going to go on the outside. That's how you take a fraction and turn it into a division problem. I get it. So the bottom is the horse. Yeah, the cowboy rides the horse. So what these terms are your divisor and your dividend, right? Your dividend is your numerator, your divisor is your denominator, and their result is your quotient. So those are words you should have learned in elementary school. Dividend, divisor, quotient. Dividend, divisor, quotient, okay? All right, so we're going to still follow that same process, but it's going to be a little different, okay? We are dividing our leading coefficients, okay? So not our leading terms. So we have x and x squared. Are y'all with me? So we're asking ourselves, x squared divided by x is x. With me? Okay? So we already did the d. After we do the d, we're going to multiply. So now, x times x is x squared. X times 5 is 5x. Agree? Yes? X. Okay, let's. X times x is x squared. X times 5 is 5x. Yes? Okay. The next thing it says we're going to do is subtract. So I'm subtracting each one. You know you did it correct because your first should cancel out. And then you're going to combine. So you have negative 6x and negative 5x, and you have negative 11x. Yes? And then we bring down. So now we're going to bring down the 7. Are you with me? Okay. And now we're going to repeat it again. Okay. So repeating again. Now we have negative 11x divided by x. What's negative 11x divided by x? Negative 11. Okay. Now we're going to multiply. So we're multiplying negative 11 times x. Negative 11 times 5. Okay, let's do it again. Negative 11. We're multiplying. We're on the in part, right? So we're going to multiply. When you have a binomial or polynomial, what you multiply one term by, you have to multiply every term by, right? So negative 11 times x, negative 11 times 5. Are you with me? Okay, so negative 11x, and that's going to make negative 55. Yes? So now we're at subtract. So we already multiplied. Now we're going to subtract. When you are subtracting polynomials, that's essentially just changing their signs. Right? So 7 and 55 makes 62. So that is my R, right? My quote unquote remainder. What we need, all we need is the x minus 11. And that is your slant asymptote. So our slant asymptote, our SA, is at y equals x minus 11. That's beautiful. Okay. So when I subtract, I'm changing, you can't just change, you're just changing the signs because you're distributing. Let me do it. So when we had negative 11x and we had negative 55, and I'm subtracting them, that's going to change the sign of each one, which is why it becomes positive 11x and positive 55. If I don't change the sign, notice that my negative 11x right here, would that cancel out? No, it would not. Okay. So that's how you know that you are distributing that negative across. Okay. All right. How do we feel about long division? Okay. It's the exact same process that you did in elementary school, just with variables now. Yeah. Okay. Same process. We divide, we multiply, we subtract, bring down. Divide, multiply, subtract, bring down. Okay. Now, some person was like, you know what? I'm tired of seeing these variables. There has to be another way of doing this. And there is. It's called synthetic division. Now, the thing with synthetic division is it only works if your divisor is a linear divisor. Okay. So this only works if basically your denominator is linear. Okay. If your denominator is not linear, this will not work. X plus 5, y equals mx plus b, linear. Yeah, slope, y-intercept. You got it. Okay, your degree is 1, right? That's how I know I have a linear function. Okay, so these are the steps for synthetic. So the first thing you're going to do is you take your denominator and you set it equal to 0. Trust the process. Take your denominator and set it equal to 0. What's our denominator? Equals 0. And you're going to solve that. So we get x equals -5. Remember, if you can't see, you can always turn on the Zoom. Okay. All right. Step 1. Step 2 is our setup. For synthetic division, it is the reverse of this. There's no house. Your house is now just a little corner. It's a little upside down. And the value you got here is going to go on the outside. Okay. It's on the porch now. All right. Now, the next part, you're going to write out all of your coefficients. Okay. You're writing out all of the coefficients of the numerator. So you're now going to write out the coefficients of numerator. If one of them is missing, so let's say I didn't have my x term, I would put a 0 in its place. So if something is missing, we always put a 0 in its place. But am I missing anything? No. I have a 1, I have -6, and I have +7. And that is the setup for synthetic division. Okay? So, questions about setup? Questions about setup? So you take the value you got from number 1, it's on the porch, right? And then you're going to set up your top by using the coefficients of your numerator. So the coefficients of your numerator were 1, -6, and 7. If I was missing 1, I would put a 0 in its place, okay? Now that it's set up, step 3 is to solve. All right, when we're solving, you're going to always bring down, that's why we put an arrow there, the first number. We multiply on the diagonal. So we multiply on the diagonal and then write its product, and we add vertically. Okay, so we multiply. So -5 times 1 is -5. And then we're going to add vertically. So -6 and -5 make what? -11. And now we're going to, again, multiply on the diagonal, write its product, and then add. Are you with me? Okay, so -5 times -11 is 55. 7 plus 55 is 62. Do you notice that these numbers are the same that we got on the left side? Our remainder is the same, and it's just the constant and coefficient. Do you see that? So therefore, now that you did your process, step 4 is to add your variables back. Add variables back. When you add the variables back, you divided out one variable, right? We divided out a variable. So if I started off as an x squared, my variable that I'm adding back is just going to be 1x, right? So 1x and no x. So therefore, my slant asymptote is at y equals x minus 11. Okay? Whichever way you choose to do it is up to you. My job is to show you both. Okay? Yes? How we feel? Okay. Now I will tell you, long division works with every polynomial. Okay. Every polynomial you can do long division. Synthetic, it only works if your denominator is what? Linear. Okay. You only can do synthetic when your denominator is linear. So make sure you make that note like, Miss Jones, I keep working this problem. It's not working. I don't understand. It's not linear. Okay. If it's not linear, you cannot do synthetic. Capiche? All right. That is it for 1B.7. Questions, comments, concerns about 1B.7? No? Okay.